Hello everyone, my name is Amber Burch and I'm going to tell you what all the buzz is about. It's about honeybees. Honeybees, by definition, are winged insects that collect nectar and pollen, produce wax and honey, and live in large communities. What is not included in the basic definition is the fact that bees are pollinators of hundreds of economically and ecologically important crops. Honeybees contribute over $14 billion to the United States economy. They also enable the production of over 90 commercially grown crops in North America. However, the population of honeybees has been significantly decreasing for more than 3 decades. This problem needs to be addressed to ensure the sustainability of our current food production system. In the 1940s, there were roughly 6 million managed honeybee colonies. In 2015, there were only about 3 million managed colonies. Many crops are heavily dependent on the commercial pollination, therefore a reduction in the honeybee population poses a real threat to domestic agriculture. There are several causes of the population decline, one being the introduction of the external parasite. In 1987, these mites feed on the blood of honeybees until they eventually die. Another factor is colony collapse disorder, which is when a healthy colony experiences a mass disappearance of worker bees with no explained reason. However, the portion of losses directly caused by colony collapse disorder has been decreasing over the last 4 years. So I wondered, if colony collapse disorder has been causing fewer losses over the last 4 years, why hasn't the honeybee population increased at all? This question led me to further research into the causes of population decline. I found that honeybees are struggling to survive through the winter season. Since 2006, beekeepers have seen colony loss rates increase to an average of 30% compared to previous loss rates of 10 to 15% during the winter season. This increase in the overwintering loss rate is caused by a combination of stressors. So, with this background knowledge, I decided to pose a question: what are the effects of breed, location within a hive, and time of year on the effectiveness of honeybees preparing for the winter season? My first independent variable was breed. I chose to use the Italian honeybee because they are known for their extended periods of brood rearing, which is the reproduction and growth of honeybees. This extended period allows the colony population to be built up in the early spring and throughout the fall. The second honeybee I chose was the Russian bee. These bees were brought to the United States with the purpose of genetic improvement of mite resistance and managed honeybee stocks. Research has found that Russian bees have fewer than half the number of mites found in other commercial stocks. And the second independent variable was time. The data in this experiment was collected from June 25th to November 1st, which was 129 days. The environment and time of year are known to affect honeybee colony preparations for the winter, because honeybees emerge from their hives early in spring and begin collecting nectar and pollen in order to start preparing for the next winter months immediately. I used standard Langstroth hives for all 4 colonies. The picture on the left shows one of the hives before the experiment began, and the picture on the right shows all 4 hives in the bee yard. During transportation, honeybees are contained in wooden boxes with screened sides and a tin can filled with sugar water, as well as a queen cage inside. They were introduced using standard Langstroth methods. The third and final independent variable was frame location within the hive. Honeybees start working from center frames before moving to outer ones. This can get kind of confusing, so I made this diagram, which is what the inside of my hives look like from left to right, frames 1 through 8. So it's clear that frame 4 and 5 are in the center, so I predicted that the honeybees would start working on those 2 frames before moving to the outer ones. For my hypothesis, my alternative hypothesis states that if Italian and Russian honeybees are established in hives on the same day, that Russian honeybees will have a greater percentage of honeycomb occupied. The C represents the coverage, and ITA is Italian, and RUS is Russian. And our hypothesis states that if Russians and Italians are introduced on the same day, there will be no change in the percentage of honeycomb occupied between the 2 breeds. For my second independent variable, measured as the number of days from introduction, I hypothesized that if an inspection is conducted once a month, then the percentage of honeycomb occupied will increase with each inspection. The null hypothesis states the inspections the percentage of honeycomb will not change from previous inspections. For my third independent variable, frame, I hypothesized that starting with frames 1 through 3, the percentage of honeycomb would increase until frame 4, and then the percentage would decrease to frame 5. All of the hives were opened once or twice each month for inspection. Each inspection was conducted by 2 people. The frames used had 6,800 outlines of cells. The pictures taken during the inspection were printed and used to count the number of unoccupied cells. That number was then subtracted from 6,800 and then divided by 6,800 and multiplied by 100 to give the percentage of honeycomb occupied for any given frame. The data collected was organized in Excel to calculate the average and standard deviations, and ANCOVA was run on the data because I had 2 categorical independent variables and 1 continuous, and my data also met the assumptions. This graph shows the breed of honeybee on the x-axis and the average percentage of honeycomb filled on the y-axis. Each hive progressed at a slightly different pace. However, the average percent of honeycomb filled for 2 colonies of Russians and 2 colonies of Italian honeybees were very close. The average for the 2 Italians was 31.8 and the average for the Russians was 35.4. The standard deviations for both sets was also very close, Italians with 40.6 and the Russians with 41.3, which makes sense because there was going to be a high variation when taking data from 2 separate honeybee hives and averaging them. The ANCOVA gave a p-value of 0.116 for breeds, therefore the different breeds did not have a significant effect on the percentage of honeycomb occupied. The null hypothesis failed to be rejected. On this graph, the x-axis represents time and days from inspection, and the y-axis represents the average of honeycomb filled. A positive linear relationship between time and percent of honeycomb filled can be seen. As time increased, the percentage of honeycomb also increased. The average percent filled for all 4 hives on the last inspection, day 129, was 53.8. The ANCOVA generated a p-value of less than 2 to the negative 16 for the independent variable time. Therefore, it had a significant effect on the percentage of honeycomb filled, allowing the null hypothesis to be rejected. The x-axis on this graph represents frame, starting from 1 and going to 8, left to right. The y-axis represents the average percent of honeycomb filled. As you can see, the data forms sort of a positive parabola shape, peaking at frames 4 and 5. The average percent of honeycomb for all 4 hives on frame 4 was 69%, and on frame 5 it was 77%. The error bars show high variation for each frame, which is expected because the data set used was so large, because all 4 hives were average for each frame. The ANCOVA gave a p-value of less than 2 to the negative 16 for frame. Therefore, the frame location within a hive did have a impact on the percentage of honeycomb filled, allowing the null hypothesis to be rejected. My experiment faced a few uncontrollable situations. I established the 4 honeybee hives 5 days after the official start of the summer season. This is not ideal because the bees miss the entire spring season, which has high nectar and pollen flow. However, this was not by choice. The first set of honeybees arrived on May 2nd, 2016. When the package was picked up from the post office and opened, nearly 50,000 honeybees were dead. The wooden box contained 10,000 bees each, and more than half of each wooden box were dead. The cause of this awful situation is still unknown. The supplier was contacted and the new bees were on the way, but it did not arrive until June 25th. The surviving bees from the first step were established in a new hive to allow them to build their colony population back up. Although the breed of honeybee did not have a significant impact on the percentage of honeycomb filled, the observations noted through the experiment make it possible to assume that the 2 sets of Russians were more effective at preparing for the winter season. One major observation noted during multiple inspections were wasp nests found on empty frames in both Italian hives. This indicates that the colonies were not strong enough to protect their hive from intruders. It was also noted during inspections whether there were a visible number of larvae developing on each frame. It is important to observe to make sure you can see a visible number of larvae so you know the queen is doing her job and laying enough eggs for the colony population to be built up. I saw more larvae in the 2 Russian hives than I did the Italians, so I concluded that they had a higher colony population, which allowed them to collect more nectar and pollen to make honey and allow them to have better storage for the winter season coming up. If a hive is not prepared for the upcoming winter season, it faces the possibility of not surviving. Honeybees are facing the problem of lack of forage material, like natural wildflowers. These flowers need to be more abundant in our areas so during the spring and summer, honeybees have access to them. Honeybees are efficient at transferring pollen from male to female plants so they can reproduce and create much of the food we eat. There are no other insects in the world that can contribute such a great amount to the amount of food humans intake daily. We need to save the honeybees so we don't lose all of our food we eat every day. The time at which my experiment was run did significantly impact the percentage of honeycomb filled. However, I do believe that if my first set of honeybees were not dead upon arrival, they would have had more time to collect nectar and pollen and make honey for the winter. It is extremely important with the current decline honeybee populations to make sure beekeepers establish new hives. They give them enough time to prepare for the winter season. A good time to establish new hives is within the first 2 weeks of spring. That is, so a colony will have 3 seasons before the winter to collect nectar and pollen and make honey for their hive. I'd like to give a special thank you to my dad for inspiring me to do this project and teaching me everything I know about honeybees. I'd also like to thank my mom for being emotional support the entire way through, as well as other family members and friends. I'd also like to thank Mr. Dutton for meeting me almost every week to answer my endless questions. Thank you for coming to my talk.